All right, we are live. Good evening, everyone. Welcome to our another live chat that is going on right now. A couple of housekeeping things before we begin. First of all, no live chat next week, but we will have it returning November 9th. Got some things going on, so next week is not going to be a live go. So we're going to skip next week and then return November 9th and then go through all the rest of November on Wednesdays because Thursdays become more festive in November, i.e. Thanksgiving. So that is the first one. Of course, we'll be taking your questions tonight and answering all of that. And of course, just want to remind you, some of you guys who are on YouTube, that of course we do have our premium membership for $11 a month or $80 a year. So definitely check that out. We'll talk about all sorts of things. Of course, all questions will be taken from the premium tier. I got a couple of good ones. One on La Nina. Of course, we'll talk about sports at times. Talk about baseball and football. And also take some of the best questions that are from our YouTube chat, which I finally figured out how to fix. Apparently, I wasn't on live chat. I was on top chat, which some messages are blinded away, so I got just live chat now. So now if there are more questions here on YouTube, I'll actually see them and pick out the best ones. So let's begin with some data, shall we? There's a lot of stuff that we could talk about. I guess we could start with La Nina, as I got a question on that first, and we'll work our way down. Excuse me. Okay, there we go. I had a good dinner, so there we are. What are you expecting to going on? What are you expecting to going on with La Nina now through February 2023 with the slow breakdown happening? Okay, part of that is the winter forecast aspect, which I strongly suggest reading the whole winter forecast and the section specifically on La Nina to get more details. But here has been my idea and continues to be my idea. And I'm going to show you a couple of data points on this. So first of all, we have an east-based La Nina with a warm PDO signal here. Okay, now the PDO is going to fluctuate from here, on back and forth throughout the winter, which is typical. But the overall theme here is a warm northern Pacific and our La Nina signal. East-based La Nina with a warm northern Pacific only happened in 5 years. So let's pull up the data here. In fact, I probably should have done this to begin with, but whatever, we'll just jump right into it. Premium dashboard. I want to make sure I get the 5 years right, because there's only specific 5 years that are associated with that La Nina. Again, the premium section, you go right into the page here and you go see exactly what you want to look at. So let's look at page 18. Scroll down. And here we have a La Nina. Now, the years in which match this current environment. And it's very important to understand that with the current state that we are in, that none of these years are going to be an exact match. I know a lot of people like to take specific years and try to match them together and try to figure out what the forecast is going to be. Because of the volcanic influence, all that has to get thrown out the window, at least to go from one-to-one association. But the only years that match the current Pacific sea surface temperature anomalies is 1908 and 09, 1938-39, 1984-85, 1995-96, I know everyone zones in on that, and 2005-2006. Of those years, 95-96 was the only one that featured a weak polar vortex. So, I know everyone's going to zone in on this. The year that matches best for this environment is 95-96. It features a weak polar vortex. We have a weak polar vortex now. It features the same sea surface temperature anomalies. but not the same Atlantic anomalies, and not the same stratospheric environment in terms of the moisture influence, the 10% above normal precipitable water value or water vapor mass in the stratosphere, which none of the years do. Again, because this is like kind of like a once in a lifetime scenario. But now we understand that, I want to pull up this data. This is the angular atmospheric momentum. Now, the AAM is good to see, is good to use when you're trying to see whether or not there's going to be changes in the atmosphere, okay? So what this is, I'm trying to use this in most basic terms possible because it's far more complicated, and to get into all the nuances of the AAM, I'd have to hold a college class, and we'd have to be sitting here for about 3 months, which none of us wants to do. Well, some of us wants to do that, but I digress. Basically, it's the motion of the Earth, the motion of the atmosphere with the Earth, with the Coriolis effect, and how that's impacted with various lifting parameters on the Earth. Make it real simple. When it's negative, La Nina. When it's positive, El Nino. Okay? So, typically, with a La Nina, especially a moderate east-based La Nina, right now, it should be negative. The current state, and let's see here, positive. Missing data, but it's positive right now. On here, European data, positive. The anomalies, positive. And then this is like your 45-day forecast. And right now, as of the release, it was positive. Why am I pointing this out? Because the atmosphere is acting the exact opposite of what La Nina should be producing. Complete opposite. I have my coffee on that one. Now think about that here. East-based moderate La Nina. This is no slouch here. It's not like it's barely hanging on. You have SOI influences, 18.29 on a monthly, seasonal 15.4. That's a moderate level in terms of atmospheric influence. And you have your sea surface temperatures clearly in the moderate range in the eastern zones, weak to moderate in the western zones. But still, the atmosphere is saying, nah, El Nino. Now, why? The reason why is because we're seeing a mass displacement going on here, which we talked about this in great length last week. So, to copy and paste, this is La Nina, this is what happens, is a huge error. And we have all the warning signs there because this feature right here should not be anywhere near positive for any long period of time. Sometimes you get a spike, okay, via movement of the MJO or something of that nature. That's different. That's, when you have like something like, oh, it spiked, it touched zero, touched neutral, pushed a little bit close, and it fell off. No. This is where we are seeing observations over 1 and then bouncing around and remaining positive all the way through December. This is a sign of atmospheric change and a significant displacement of forcing parameters that is driving this signal. So the idea here is that La Nina will weaken, but I don't think it's going to produce the influence that many people think it will. What I think we're going to see is that right now, and let me pull up the water vapor satellite picture, if I keep on finding the right one. It's around here somewhere. Okay, here we are. Okay. This is the globe. Hello, globe. And this is our subtropical jet stream. In fact, let me show a different look at it. Now this is even better. Okay. This is the winds. Okay, I probably should have done that first. But You get the idea that the subtropical jet stream shows up pretty nicely on the water vapor satellite picture. And hello, jet streak. In a moderate La Nina right now, with this AAM signal, you are getting, as a result, a pretty robust subtropical jet stream. So as La Nina weakens, I think the subtropical jet stream is going to intensify, in which that we're going to see more moisture transport, we're going to see more short waves involved, but it's not going to change the orientation and forcing parameters of the pattern configuration, i.e. your high latitude blocking regimes. Okay? I think the polar jet stream is already amplified because of the La Nina influence and the difference in the thermal gradients. I think because of these different factors all coming together, we're seeing a mass transport. And this is something I kind of pulled up to kind of make my point here. This is the polar vortex here. And this is a forecast on the GFS of the polar vortex. Okay, now notice it kind of gets a little bit wobbly here. Here's North America. And here it's kind of like a big tornado, right? I mean, not actually a tornado, but it looks pretty cool in this demonstration, which you can find from stratobserve.com. It has excellent data here, all from GFS. I mean, it's from a figure created by D.D. Lawrence, observations data sources at GFS. You can create this yourself if you're, computer savvy and you're good at creating graphics and whatnot. I am not, so thank God for people like this to create this type of demonstration here. So you could see when you have a strong polar vortex, you have a very tight circulation. You don't get these wobbles. You don't get this displacement. You don't get this, okay, where it's kind of like wobbling all over the place. It's not really fully displaced, as in when you kind of get like a split, but this is no strong polar vortex. And even as we go over the next 10 days, we should see a strengthening, because it'd be very unusual to have the polar vortex not strengthen at all as we go through towards November. Just in the natural state of the atmosphere and the natural evolution of these type of features dictates that you should get some strengthening. And that's what we have over the next 10 days. But even with the strengthening, which look, this is definitely stronger, you could see on the European clearly a warping and pushing, a displacement, even with strengthening. And you could see this feature right here. This is mass displacement. Again, this all goes back again when we started with talking with La Nina, how that's going to influence. We talk about the mass displacement. We got moisture. You have the atmosphere acting unusual compared to what you would expect with an east-based moderate La Nina. Even with a warm northern Pacific, you have a weak polar vortex environment, and now you have this displacement. And it's important to remember, because even with this feature showing up, a lot of people put a lot of stock into the snow over Siberia, and let me pull that up here. And clearly over the past 10 days, we've seen an increase in the snowpack, probably end up average, maybe slightly a tinge above normal by the time we get to October 31st on Monday. But I don't think this is going to be a major driver in terms of displacing the polar vortex and influencing it and impacting the weather pattern, because I think that the forcing mechanisms are already there. And that is where I'm going to show you some really cool data. So there's our vortex. Here is, and again, this is via the GFS. Right now, this is our heat transport. Eddy heat flux pushing into the higher and mid latitudes here. And we see it developing right here and pushing back towards Greenland. 10 days out, we see that even more. Again, heat. Why is that important? Heat in the stratosphere. This is why it's important, because the heat in the atmosphere means that it's warming. We're seeing a warming taking place. The warming causes a stretching and disruption of the polar vortex circulation because heat in the stratosphere leads to expansion. The expansion leads to contraction in the lower levels of the atmosphere. Remember, the stratosphere can't expand out into space. Okay, the atmosphere cannot expand out into space. So you have a hard cap, right? Kind of like the NFL hard cap, right? It runs right into that cap. It cannot go above that cap. So because of that warming that's taking place here, it runs into that cap and has to get pressed down. When you press down on the troposphere where we live, that's here. That's where you talk about 500 millibars, 700 millibars, 1,000 millibars of surface. That means this shrinks. And when that shrinks, it leads to below normal heights in spots, and it leads to above normal heights in other spots, i.e. high latitude blocking, upper level lows, chaos, and everything. And possibly the Ghostbusters, who knows. But this factor here, already showing up, is a signal of that heat transport and that balance that we're talking about because of the volcanic influence. Because remember, there's a basic law, and this is true of climate change and everything else. No matter what you believe, the atmosphere is always looking for a balance. That way it can find its center, so to speak. So, when the atmosphere is trying to find its balance, that leads to why we have storms, why we have strong cold fronts, why we have high latitude blocking. It's all to find a balance in the atmosphere. And that volcano, when it introducing all of that water vapor into the upper portions of the stratosphere in the southern hemisphere, it led to a massive imbalance, which the atmosphere is trying to create a balance for. So you had rapid cooling in the mid-latitudes in the southern hemisphere, and so you must find a balance to that influence that is still in place. And that is what we're seeing here. And it's just the beginning. And oh, by the way, this is your EP flux. This is right now. That influence, you could see it working its way towards the equator, moving like this. Now, what you want to see, if you're looking for a massive, significant stratospheric warming event and disruption of the polar vortex, you want to see these arrows point here a little bit. So let's go 10 days out. Oh, look what we have here. A little shift. Just enough. Now, 15 days out in the GFS is a bit questionable, but let's check it out. And this is why it can be a little bit questionable, because now you have all these vectors clashing against each other. But this is interesting to me in seeing this feature right here, this heat flux right here. A lot of heat building towards the upper portion of the stratosphere, impacting stratospheric environment. And we're just beginning. And again, what I always suggest, start at zero, look at the environment that we have in place, and then ask yourself, as you look at the forecast, not just, hey, look, the GFS is doing this, or the Europeans doing that, but ask this. What is the forcing parameters that causes that? And it's all about mass displacement and a basic law of physics. I hope I answered that question. So there is a lot going on. Yes, well, look, the Yankees' loss was disgusting for Yankee fans. But at least you got the ALCS. Because my Mets, I got nothing to say. I'm a Mets fan. I got nothing to say. You know, I don't know what to tell you. You know, I feel your pain. I felt the same way with San Diego, where I'm like, okay, look, you lose the series, fine. But can we at least get a hit? Or can we at least get a run in the last game? That was rough. Okay, looking at Earth News School, one thing that I noticed at 70 millibars is that there is only a steady stream of warm air north around the pole, but also cold air being sent south from the pole to the equator. Also notice at 70 millibars and 10 millibars some equatorial spillover. I don't recall seeing this much to this extent, typical or not sign of the water vapor from the volcano. Okay, let's take a look at that. Okay, so let's pull up. And by the way, Earth.News School, for some of you guys who are new to following, completely free. You could just Google it. Boom. You can look at this data all day long. It's beautiful stuff. So let's go to 70 millibars. Okay, so a couple things I'm noticing here is that, geez, this polar vortex is still pretty weak. I mean, this is just, it's not very impressive in terms of its strength. When you're looking for a strong polar vortex, you see these strong winds here? You usually see that wrapped around like a donut. Almost like a very strong circulation. And this high up in the atmosphere, it's very easy to get those strong winds wrapping around a strong circulation. Now, let's see. I think I know what part you're talking about here. The spillover. Okay. All right, I see what you're talking about here. See this interaction right here? It's not that unusual to see this. I wouldn't call this too unusual. But I wonder if... Let me see something here. The temperatures are so cold here, it's hard to... See, there is like that colder pocket right here, but the color scheme is such that it doesn't allow me to really just stand out. Oh well. It's better off in other data. Let's see here. Winds. There we go. But you could definitely see the orientation of the polar vortex as well. Suggests atmospheric transport from northern Asia, i.e. Siberia, towards North America. So that's an interesting scenario as well. The winter forecast PDF and discussion today alone are with the annual membership cost. I appreciate that, Cart. Thank you. Did you see the coronal holes in the sun are making a smiley face? Yes, I did. I talked about that in the long range thoughts this evening. Pretty cool stuff. Going to be impacting the atmosphere. And that's an interesting aspect with the solar impacts. Here, let me see. Space weather. I like to use spaceweather.com for my solar data. They do a great job. What I find interesting is that we're seeing a pretty active atmospheric environment, solar activity. And what that does, overall, it leads to a cold stratospheric environment. Now, that leads to some very interesting potential here. The overall stratosphere, especially the upper stratosphere, tends to be colder when you have a very active solar activity. Because what it does is that all that solar activity starts to break down and impact the ozone in the stratosphere. Okay? And that breakdown leads to cooling. All right? Now, there is kind of like this fight going on now. Because you're seeing this transport going on from the troposphere to the stratosphere. And then you're seeing this mass displacement at the same time because of solar activity, right? So solar activity impacts on the stratosphere never is uniform. It leads to these cold pockets and warm pockets. So when you have a quiet sun, you get a warm stratosphere overall. So the warm stratosphere overall leads to a weaker polar vortex overall. Not always, but most times. Then when you have an active sun, what you have is a colder stratosphere overall, but it's not uniform. So you get these pockets showing up. This year, we're seeing the pockets showing up quite frequently around the northern Pacific, around, let's say, portions of Russia into Alaska and northwestern North America. That pocket leads to an enhancement of warming that takes place in that zone, which pushes down on the troposphere. And that is part of the reason why I think we're seeing this continuous influence of a trough bouncing around anywhere from British Columbia to the Aleutians, okay? When it's in the Gulf of Alaska and around British Columbia, like will be for this upcoming week, then you end up with a warm weather pattern. So essentially, you end up with what we have here. You get a nice ridge in the east. It's very nice and quiet. But everything that's going on here that we've been talking about leads to this trough intensifying by the middle of next month. I'd say November 15th, 16th, look for a flip. And when that flip happens, oh boy, what's going to happen is that you're going to get a trough around the Aleutians. This gets kicked to the east. The ridge builds over the Rockies. And you start to see a pretty significant trough over the eastern United States. And watch out for the potential for a negative NAO pattern. I sense Thanksgiving is going to be rather stormy. I still need more data, but everything I'm looking at here, including observations like what I'm seeing here, tells me that we should see some very interesting activity on the way. Tropical jet is rip-roaring as if we're anything but a La Nina. Yep, very true. So far, it looks like your idea that mass displacement from water vapor from a volcano is on the money. We shall see. We have more time to study this, and I'm not declaring victory in any way, shape, or form because, again, I'm kind of going off on the extreme limb with it breaking, okay? Because there's no data, really. I just kind of sat there drinking my coffee, trying to figure out the winter forecast, and I'm like, maybe it's as simple as just for every action, there's an equal and opposite reaction. And if you have an action where you have significant cooling taking place in the stratospheric levels, as we showed last week, if you want, I'll bring it up again. Let's see here. Observations, stratosphere. Some of you guys who may have missed it last week, I will pull it up. Okay. So, again, here is the southern hemisphere. Mid-latitudes. That is cold. That's historically cold. This line is supposed to be your records. This is below the records. And this is all because of the water vapor in the stratosphere. Now, a lot of people say, hey, the water vapor should cause warming, right? I'm sure you guys seen a lot of that in various news stories, right? And it does. The water vapor does cause warming. It is a greenhouse gas, absolutely. Problem is that a lot of the assumptions were based on the idea that the water vapor distribution was uniform. It wasn't. And that's an important feature. You see, it was all focused over the mid-latitudes of the southern hemisphere and kind of bled over the equator and a little bit around the tropics. So let's say around northern South America, parts of the Caribbean, let's say around Central Africa, those locations, okay? So we had that, but it didn't get anywhere further north, really. Wasn't anything significant. So we saw what the impacts were in the southern hemisphere, and we could see it right here. Here's the eruption in January, and then you saw the impacts. And it just got worse and worse as that plume of moisture expanded. As we moved through June, July, August, and remember, this time period is their winter, okay? So then, let's see that same time period up in our neck of the woods. Pretty much on average. When you're in this zone, you're pretty much average. Slightly below normal, but nothing too impressive. And then, let's take a look at 50 millibars in the high latitudes. This is where we take a look at our high latitude blocking. And look at that. Pretty much average to above. So we're not seeing any impacts here from the volcano at all. So then if you have a displacement, and you could track the displacement by the impacts and the influences of the temperatures in the stratosphere from the water vapor, then you know that there is a thermal gradient, and there must be a balance of that thermal gradient. Is the cold air from the polar vortex region being pushed south to the mid-latitudes and warm air going to the north, something that can feed back on itself and become sustained at that level of the atmosphere? I think that there is that process developing, but I don't know the details just yet. I kind of want to see how this all plays out over the next couple of weeks. Fire and brimstone, cats and dogs living together, that kind of chaos. Yeah, pretty much. Last winter, we didn't have many long stretches of sub-freezing temperatures. Will that be a trend again this year? The way that the pattern is evolving, and if you take some of the La Nina influences and you take some of the pattern evolutions, I would say your best shot for sustained sub-freezing, sustained air would be over the northern plains and Great Lakes. I don't like forecasting sustained sub-freezing temperatures in the northern mid-Atlantic because of the influence of the Atlantic. I think that's a bold statement. I think your best shot would be the Poconos and the Catskills to see that type of environment. But that's where I would go on that. Historically, climatologically, if you get from the Delaware River Valley to the coastal plain, you typically, unless you have like a really impressive Arctic blast, you end up with on average temperatures, in the upper 30s to lower 40s, which obviously isn't sub-freezing. So I'm not really prepared. I would say I'm not prepared to say that, but I am prepared to say that the potential this year for an Arctic blast is much better than it was last year. Last year I played up a lot about how the atmosphere, how the air masses are going to be very volatile, and that you're going to see spikes of warm and cold, and you're going to have a lot of storms that are going to be tracking over the region, a lot of wintry mixed stuff. I'm not saying that this year. This year, I have more confidence in polar air masses invading, but to go with the sub-freezing sustained weather pattern is climatologically below normal, well below normal, and something that would support a sustained Arctic blast, which I would never forecast for a seasonal forecast as being 100% confident. I would just say that the possibility is there. I wonder if there is data as the ozone levels pockets for those 5 La Nina years that you noted on the winter forecast, whether 95-96 differed from the other 4 years. Unfortunately, I tried to find that data. I couldn't find it. So unfortunately, I don't have the answer to that. I did look at the stratospheric environment of 95-96. Solar activity-wise, it was different. The way that the stratosphere acted was different. It was a weak polar vortex for sure. There were stratospheric warming events, but I wouldn't go anywhere beyond that point as far as any comparisons. All right, let's check out YouTube. Let's see what's going on over there. Okay. Does global warming cause more blizzards to happen? Now that is an interesting question. Okay. So, it depends on where you are at. All right, so I'll put it like this way. So you see the oceans are pretty warm here, right? Now this is part of an aspect of global warming. Okay, it is an aspect of it. If you have very warm waters in the northern Atlantic here, and you get a strong polar air mass, yes, it could enhance storms. But The fact of the matter is this, that according to the IPCC, I think I got that right. I always mess that up. According to that, we do not have strong observational data to point one way or the other for blizzards, tropical cyclones, or limited data on heavy rainfall events. We have very strong support for global warming influences on the development and enhancement of droughts and the rate of heavy rainfall. And that's directly connected to precipitable water values, which I've brought up in the past. In terms of winter storms, I wouldn't call it global warming, but I would say that there's definitely a man-made influence in this respect. And you'll see it this winter. Urban heat island effect around New York City, Philadelphia, the I-95 corridor. This is a great example, okay? It leads to these pockets of warmer air. And the warmer air rises and leads to more convective, slantwise convective environments, which leads to more mesoscale banding within winter storms. And because of that mesoscale banding, you could end up with winter storms that drop 2, 3, 4 inches of snow per hour in a localized area. So it's not a widespread event, but you get these pockets where you end up with, Newark getting 30 inches of snow and Central Park getting only 15. Because a mesoscale band sat right over them because of the urban heat island effect. And we also see this in the summer with thunderstorms, where we get some enhancement, some thunderstorms train over each other, and you get like 5 inches of rain, right? So there are those aspects. One thing I would say, never, ever, whether it's climate or anything with atmospheric science, declare an absolute. Because the very nature of the atmosphere is chaotic, and you cannot go with absolutes. You go with guardrails. What you're thinking of if winter starts earlier this year in the east? Typically in La Nina years, you start off winter a little bit faster. Okay, so you start off like in mid-December, even sometimes early December. And climatologically speaking, you start to taper off in February, and March ends up being pretty mild. This year, though, we should see La Nina weekend, and we already talked about the other aspects. So this could be something where we get December, we start off really impressively, then we back off in mid-January, and everyone screams winter's over, oh my god, the end of the world is here, and then it rebounds again. We get another string of storms in February, backs off, and then we get another string of storms in March. I could definitely see that being a theme. Okay, let's see. I wonder. Saw a story today about caves in Arkansas that are now exposed by drought. They were used in the Civil War as a haven for spies, thus 160 plus years ago, were dry before they later became submerged and now recently exposed again. Yeah, see, here's the thing. Here is the issue with trying to connect climate change to every aspect of our weather pattern. And then you have other people saying, well, this happened before, therefore that the whole theory is bunk. They're both wrong. Climate change does not mean that the same thing never happened before. Perhaps the intensity is different. Perhaps the lifting parameters are different. Certainly a factor. But historic droughts that we've had, let's say in the plains, in the Rockies, like the mega drought that wiped out an entire civilization from 1190 to 1230. Okay? Those will happen again. In fact, it's happening now in the West. that has nothing to do with climate change from us. However, what we've done to the atmosphere by introducing CO2 and methane, among other things, does enhance that drought. It doesn't mean that if we weren't here, it wouldn't happen. It will happen. It is going to happen. It will happen again. But we make it worse. It also doesn't help that you have these idiots who build golf courses in the middle of the desert and then wonder why they don't have any water enough water. So, there's that aspect. Winter with a January thaw and then a late gasp in New Jersey. Who would have thought? Yeah, I know. It's pretty much standard. I'm just kind of explaining the standard because I already know how winter is going to... I already know the social media winter. Okay, I'll put it that way. The social media winter is this. We get a winter storm in December, and then thus it's the greatest winter of all time. Then you get a couple more activities into early January. Then you get a warm up in mid-January. Everyone screams winter's over for whatever reason. And then winter forecast a bust, blah, blah, blah. And then you get everyone just saying, oh, get ready for spring. And then we get another switch back. We get another couple winter storms in February. And then people start to complain that winter's never going to end. And then we get maybe one more storm in March. And then there you go. That's usually the way that winter goes on a social media world. Okay? No matter what happens, no matter what year, no matter how much snow you get. Let's see here. Got a couple more questions on YouTube. Do you think the fact that this is a third-year La Nina is a big deal? It would have been if we didn't have that volcano influence. I strongly believe that. Because then what I could have done is taken the third-year La Nina influence and compare it to other years. The fact of the matter is that not one of the other years that featured a third-year La Nina, not one, had a similar Northern Pacific environment nor stratospheric environment. So if you don't have the same environment for any of those other La Ninas, then what happened with that third La Nina in other years is immaterial. It doesn't matter. Okay? So you just throw it out. The fact that it's the third-year La Nina, to me, isn't important. The fact you had two La Ninas beforehand has no influence on the forcing parameters that are in play right now. When you have an AMP and EPO doing what with La Nina over time, weakening it, I'm not sure what that means. Okay, so... Oh, I see. Positive. And EPO. I see. Okay. All right. So, I think what's happened with the AM is a signal. It's not a driver. I think what weakens the La Nina is the fact that you're losing support in the atmosphere and with the subsurface anomalies. And I talk about this in long-range thoughts under La Nina. But I don't think the AM is what's weakening it. I think it's a signal of that weakening that's on the way. Let's see here. So far, we got more questions here. Let's see. All right, so I got a couple ones from Card here. There's a difference between climate change and attributing it solely to people's activity. Nuances are not considered by many who are trying to make politics rather than study a science test theories against data adjusting as we learn. Okay, so unfortunately, climate change has become a political football, and it has been for a long time. The way that we address the energy we use and all that stuff, well, let me put it this way. Gluing yourself to Van Gogh isn't going to change how we handle energy. You still have to heat homes, and you still got to feed people, right? So the best way, personally, and why I am very much a positive person about where we go in technology is technology. I'm a big believer in technology. And I think that we'll be okay as long as we invest and as long as we use our brains. I think we'll be fine. You do a good job of looking at it the way scientists should be looking at it. I'm just doing the way I normally do it. Look, I got no bone to pick politically. It doesn't. I don't. Look, I vote for myself, right? So it doesn't matter to me. I'm just telling you what I see scientifically. And I see a lot of people who make a lot of over-the-top statements either against climate change or for climate change, and they're both wrong, and I call them out daily. None of the third-year La Niñas had the subtropical jet stream that we have this year. Exactly. So you're dealing with an environment that's completely different. What will the main driver this winter, EPO, MJO, etc.? I think the EPO will be your bellwether in terms of the signal of telling you what pattern to expect. So when the EPO drops negative, that's when you can start to see 5 to 10 days later the setup begin for a major string of winter storms. So that's your signal. Okay, that's your traffic light. The driving mechanism will be I want to make sure I phrase this correctly. The ebb and flow of the EP flux transporting mild air from the mid-latitudes from the tropospheric mid-latitudes to the stratospheric high latitudes. And that circulation that interrupts and impacts the polar vortex. Once that happens, then the next feature we have to consider then is then how do the polar and subtropical jet streams interact and how they phase. So it's kind of like a 3-part puzzle, okay? Glue is what made petroleum. I wonder if those actors even realize it. Yeah, I know. Tell me about it. I know that historically the chances of white Christmas are very low. Very, very low. But maybe this could be the year it happens. Well, like I said, it's about a 5% chance. And about almost 0% chance on the coastal plain. I think it's like 1% if I remember correctly. I have to look up the data. But yeah, it's pretty low historically. And the reason why it's low historically is because of the warmer waters along the East Coast naturally, right? A lot of our winter storms typically happen not in December, but in January and February. Almost a good chunk of them. So that's why our white Christmas setup is usually pretty much low. Now, if you're in the Poconos, northwestern New Jersey, Catskills, all those areas, totally different story. But is there a shot? Yeah, maybe. I mean, if you're going to do it, then this would be the setup to start to at least support that potential. Let's see. Excellent questions tonight, guys. Absolutely excellent. Meanwhile, I forgot also to go over the... we got another question. Where does the coastal plain run in Connecticut and how far north? All right. Let me pull up. Usually, I look at the coastal plain right around here. Now, there's a little bit of a slope incline here, but I like the coastal plain right about here in Connecticut. And for those of you wondering down in New Jersey, I take the coastal plain here and cut it through central New Jersey and down. Now, what's interesting with our winter storms in New Jersey, and you can also point this out in Connecticut, is that you get these warm pockets with the way that our geography is set up here. Is you get these little ridges and valleys within this area. You get a nice bowl here. So what happens is that you get warm air that surges up the Delaware River Valley and then comes around that bowl, and you get this cold bowl right here, and And you also get that right here. And what typically happens during winter storms, you get this northeast wind, southeast wind, northeast wind convergence, and enhancement of precipitation right here. It's pretty cool stuff. Poconos often has snow at Thanksgiving. Yes, they do, at least the higher elevations. Here, if there is snow for Christmas, it's usually light. Yes. Often mixed with rain and snow. Yeah, again, it's pretty difficult to pull off. That's good coffee. Now, talking about Halloween, let me just march this up here. We have a nice high pressure in place all the way through the weekend. So I know some of you guys, you do Halloween during Saturday and Sunday with the kids because they're home. You don't have to worry about rushing back from work and all that good stuff. I get it. The weekend is going to be absolutely beautiful. Halloween itself, you have this low pressure system developing right over us. Now, when I take a look at the lifting parameters involved in here, let me see, here it is. And I take a look at this. I'm not seeing very strong organized lifting. It's scattered, it's broken up, 850s kind of blah. Not much in the way of strong thermal gradient. So these are going to be scattered showers. And then when I take a look at the precipitable water value, at the same time, not all that impressive. Maybe one or two brief heavy showers. I would say that if you're going trick-or-treating on Halloween itself, in the afternoon and evening, go out, enjoy yourself, have a small umbrella. It's not going to be windy though, so that's good. And if you don't mind the rain, if it works with your costume, then you're all good. Looks like a lot of snowfall for Canada and out west the next couple of weeks. Yes, I agree. That's going to be very important because what we're looking for in northwestern Canada and Siberia is a buildup of the snowpack to see how well it establishes the polar and Arctic air masses. That's basically our freezer, right? So we build up our snowpacks, we build up our polar and Arctic air masses, and then here they come to the south. Yeah, as far as the tropical development from the NHC, let me just pull up this. Look, okay, maybe it might produce a wave of low pressure, but this is, I don't see it. I really don't. Let me see here. Here's a water vapor. This is not a feature of tropical origin. You got dry air wrapping in behind this thing. This is an extratropical low pressure system. Now, okay, maybe you can make an argument from about the surface to maybe 850 millibars that you try to produce some sort of warm seclusion, and they try to call that a warm core low, and so they call that a subtropical depression. I guess you could try to pull that off, but the overall structure here is clearly cold core, clearly extratropical. I mean, you can see all the signals here. Here's the dry air coming in. You can see kind of like the comet. You can see the jet streaks. Yeah, and by the way, a lot of shear as well. This is just a nice plume of moisture coming right from the tropics, lifting right into the higher latitudes via a nice impressive trough. I don't see any signal of any type of tropical development, but we'll keep an eye on it and see what happens with the observations. Okay, so far doing pretty good on YouTube. And it looks like I answered all the questions here on the live chat. Outstanding. Okay, so we got everything all wrapped up, I think, for tonight. I think we'll call it a night for now, unless anyone else has any more questions. And looks like we're good. So, again, next week, no live chat. We'll be back on, I believe, November 9th. Yes. November 9th. Hold it. Is the moisture plume also carrying up warm air up to the polar regions? Yes, that is part of the transport that we're going to be watching. That is the tropospheric transport that we're going to be watching. We got another question here from on YouTube. It's what do you think about the rush to blame every single hurricane on global warming? Well, okay. I would say, I want to be very careful when I answer this. Okay, not because I'm afraid politically, but I want to give you the right answer. It is dangerous to automatically point to climate change for every storm that we have. You need to do studies, and you need to analyze the evolution of the storm. That being said, you can pick out aspects of the storm that lead to enhancement, like the rainfall rates, for example, because you have enhanced precipitable water values, so on and so forth. So you could pick that up. But at the same time, like for example, the intensification idea, rapid intensification, there has been some very impressive research on how, as this hurricane's approaching, because of the process of upwelling and whatnot, it leads to these thermal gradients within the mesoscale structure of the hurricane, where you kind of see these curlicues now on your satellite picture that we never saw before. And there's research on that in which the upwelling evolution that you see is actually leading to intensification of the hurricanes, and could be an explanation why we're seeing that rapid intensification. That has nothing to do with climate change, but clearly because we have better observational tools, we can see that intensification much better, and we can prepare for it much better, right? So, to jump to that conclusion every time is a mistake. But at the same time, to assume that it doesn't impact storms would also be a mistake. You must study each storm, break down each feature, analyze each feature, and some features will not have any indication and some will. And so what you learn from that is that the atmosphere has certain ways of balancing out the mass budget that is going on in the atmosphere. And not everything is always uniform. Everyone always wants a uniform yes-no answer. The atmosphere is chaos. There is no yes-no answer. Period. End of story. It's always chaotic and always looking for a balance. And I guess that's a nice bow wrapping back into the winter forecast, right? That's our balance. We're looking for a balance. And the atmosphere is going to find and achieve that balance. I think that's a pretty good place to end for tonight. Thank you again for watching. I really appreciate it. We'll be back again on November 9th to do our live chat. We'll see where we are at with our winter weather evolution. And as always, stay safe out there.